Matching is an important part of the work carried out by a painter and decorator. A painter and decorator should be able to basically read a colour, seeing through it and interpreting what colours are required to compose it. As a painter, there are a number of very important reasons why you need the skill of matching paint colours. You may be required to modify a colour selected by a client, create a colour unavailable on colour charts, match an existing colour, create a colour to match an architectural feature such as a tile or the carpet, etc. Or you may need to correct a colour that's been mixed incorrectly. So please pay attention to these lessons in order to gain the required knowledge needed to successfully match a specified paint colour. When light travels through water or other transparent things such as glass, its speed slows down. If you slow down light and bend it, then you can see the separate colours of the visible light spectrum. This can be achieved by using a glass prism, as illustrated here. You've no doubt seen this take place from time to time when you see a rainbow. A rainbow is simply light that has been slowed and bent by travelling through water in the atmosphere near you. When all wavelengths of light within the visible spectrum are combined, they appear as white when reflected off an object. We can observe this happening with a water-based paint that appears to be white before it dries. The reality is that when we dry the paint, it is actually clear, as can be seen here with this time-lapse video. So why did it look white before it dried? The reason is that the paint is made of molecules suspended in water. These reflect all the wavelengths of light off each other evenly and bounce all the light back to the eye, making it appear as white. We can see this with salt as well. Salt appears to be white for the same reason. When we mix it with water, we can see that salt is actually clear. When we see a colour, we're actually seeing only part of the light reflected back to the eye. The other wavelengths of light are absorbed into the surface. So it can be said that painters create colour by removing light. This is referred to as subtractive colour mixing. Subtractive colour mixing means that the more colours that are added, the darker the original colour becomes. It also means that the more colorants added to create a colour, the further away from white a colour becomes. RGB projectors, televisions and computer screens, etc. are said to be additive colour mixing. This is because the more colour added, the brighter the screen becomes, and the closer to white the surface becomes. The primary colours that make up all other colours in additive colour mixing are red, green and blue, hence the name RGB. The painter's subtractive colour spectrum has three primary colours: red, yellow and blue. When two of the colours are mixed, a secondary colour is produced. In this model, we can see red and blue. When these are mixed, you get purple. When red and yellow are mixed, you get orange. And when yellow and blue are mixed, you get green. Orange, green and purple are secondary colours. What happens when you mix the secondary colours? Well, when you mix secondary colours together, you get more earthy, dirty colours. This is because you're moving further away from white as a result of the colours being mixed, absorbing more of the wavelengths of light. When you mix purple and orange together, you get a very earthy red that may be defined as russet. If you mix green and orange together, you get an earthy lemon colour that could be defined as citron. And if you mix green and purple together, you get a dirty green colour, like olive. This can be very useful to know, as many of the popular modern colour schemes are based on earthy natural colours. Colours such as rich deep browns can be created by mixing russet and olive. You can play with these colours derived from mixing the secondary colours to create a variety of rich earthy colours. As a painter and decorator, it's a critical thing to remember the relationship between the primaries and their secondary colours. You need this basic understanding to successfully match a specified paint colour. There are 6 colours to remember, 3 primaries and 3 secondary. The primary colours are colours that cannot be made by any other colour. They form the basis of all other colours. The primary colours are yellow, red and blue. When any 2 of these colours are mixed, they make one of 3 secondary colours. When we mix yellow and red, we get orange. Red and blue make purple, and yellow and blue make green. To illustrate the way a painter relates to a colour, let's look at a basic subtractive colour wheel. The colour wheel is a model that illustrates the relationship between primary and secondary colours. The colour wheel model is basically a pie made of 6 pieces, 3 primaries and 3 secondary. In this model we can see the colours yellow, red and blue, the primary colours. When blue and red are mixed, you get purple as a secondary colour. So in the colour wheel model, purple is placed between blue and red to show its relationship with its 2 relative primary colours. This can also be seen with green and orange. You need to remember what primary colours are required to make up each of the secondary colours. This information is something that a painter should not even need to think about. It should be so deeply ingrained that if someone asks you, what colours make green, you could reply in a split second without even thinking about it. Now that we're clear on the relationship between the secondary and primary colours, we can expand our colour portfolio by introducing intermediate colours. Intermediate colours are made by mixing a primary and a secondary colour together. As you look at a colour wheel, intermediate colours are made by combining the primary and the secondary colours that are next to one another on the wheel. For example, have a look at a purple. As you know, purple sits between red and blue. Now if we introduce a colour between purple and red, we have an intermediate colour, red-purple. And the colour between blue and purple can be said to be blue-purple. Orange sits between red and yellow. Again, the colours sit each side of orange can be said to be red-orange and yellow-orange. And the same can be said for green as well. You have yellow-green and blue-green. So this expands the colour wheel model out to 12 colours instead of 6. This expanded colour wheel may assist in selecting colours for colour harmonies. We'll learn more about colour harmonies later. Another benefit in understanding colour in this way is that you can now interpret a colour as leaning more towards one primary or the other. This will assist in determining if you need to add more of either primary in order to match a colour. More effective in matching a colour, we need to consider the science behind measuring colour dimensions. To better understand the dimensions of colour, we can refer to the Munsell colour system. The Munsell colour system is a form of specifying 3 colour dimensions. These dimensions are hue, value, and chroma. It was created by Professor Albert H. Munsell in the first decade of the 20th century. The Munsell system is based on human visual perception and is probably the most conventional way of measuring colour. The principles of the Munsell colour system will assist a painter and decorator to define, understand, and interpret colour. Again, the 3 dimensions of the Munsell system are hue. The hue is its basic colour, its colour slice, be it red, yellow, blue, green, etc. Chroma. Chroma relates to the intensity or purity of the color. Value. How light or dark the color is. The degree to which the color reflects back light. The Munsell color system is very complex, and the following explanation is to provide a basic understanding of key concepts that you need to know in order to match a color. Let's look at each of these dimensions in detail for a moment. The term hue relates to the color itself, each horizontal circle on the Munsell divided into 5 principal hues. Red, yellow, green, blue and purple, and 5 intermediate hues: yellow-red, green-yellow, blue-green, purple-blue and red-purple. In principle then, when color matching, you need to identify the hue of a color first. This will have a bearing on what colorants, stainers or tinters you select to create the color. Chroma. Chroma is measured radially from the center of each slice and represents the purity of a color, with lower chroma being less pure, more washed out. For example, pink is a very weak chroma of red. When matching a color after you've selected the hue, you adjust the strength or chroma of the color little by little. The value is the darkness or lightness of a color. The value varies vertically along the Munsell model. It is solid from black, defined as a value of 0 at the bottom, to white, a value of 10 at the top. Neutral grays lie along the vertical axis between black and white, starting at number 1 and finishing at number 9. By adding different amounts of black, white or grey to a color, you can change that color's appearance and extend the range of tones of the color. So the value of a color is said to be its tone. When black is added to a color, a shade is produced, creating a deeper tone and decreasing its value. When white is added to a color, a tint is produced, creating a lighter tone and increasing its value. So when matching a color, the last thing to determine is if you need to adjust the tone of the color by adding a little of black colorant or stainer. You're not likely to need to add white to a color. If you add more of the base paint to a color, this would not be, technically speaking, adding white. Why? Well, the paint itself, even if that paint is a white base, without the tint, it can be said to be a set value or tone. So when we add more paint to the mix, you're not really adjusting its tone, you're weakening its chroma. Would you like to know more about the Munsell color system? As already mentioned, it's a very complex system and there's much more you can learn. Perhaps you could try and type Munsell color system into a search engine to find out more, or maybe you could search the terms hue, value, chroma, tone, tint and shade.